Alright. Now we proceed in more detail to the process message method. So as I said before, this is the method that's called when a client passes a message to the server, and whenever he performs any kind of action, for instance, entering an input value, pressing some sort of a button. So it depends on the experimenter to define at which part the server is invoked from the client. So some of the messages can be handled locally on the client side, and at some point the messages have to be transmitted to the server. All right. So now this is a small example of how server code, how the server can help to handle, the institution can help to handle the messages in the client. For example, you see that the process message always takes the client response message as a parameter. This message can be used to obtain the timestamp at which the client timestamp and the server timestamp at which the message was sent. And then the client ID can also be obtained from this message. Okay. So now we come to the most interesting part, which is the message.get parameters. So what you obtain is your own instance of the parameter object. So this is basically, like I explained before, this is basically the object which contains all the information that you want to pass around between the screen. For example, from the server, you want to send some information to the client. So you pass this using the string info text. And then from the client, you want to obtain the input value and send it back to the server. So for that, you use the input value. In this case, it's the amount that the requester sent, for example, that he's willing to share. And then you have the action performed. So this denotes whether the responder accepted or declined the offer. All right. So based on this, in your experiment, you can basically define your own param object, which extends the superclass param object, and then fill in all kinds of values that you are interested to pass around the client and the server. All right. So the server in this case represents the institution. Okay. Now coming back to the process message method, we obtain the parameters that were sent from the client. In this case, we get the screen ID, we get the parameter object, and then there's some small logic in this case. So for instance, the message can either come from the requester or the responder, and it always comes to the same method irrespective of the role. So what we try to define in the institution is how does the screen flow change depending on who the sender is. Okay, and this kind of logic is specific to this experiment, and it will change depending on your experiment. Right. So in this case, we have two if blocks, which is we have one if else block in which the ifs handles the case when it is from the requester, and the else handles the flow when it is from the responder. As you understood from the game, whenever the message is from the requester, we do some sort of logging here. I'll come to this in more detail. So this trial object is used to log data. And then here what you do is from the parameter object, you try to get the offer value. And then this is typecast. And then from the offer, you also calculate what is the share of the requester, right? And then, so this is by default. This is irrespective of whether the responder accepted or accepted or declined the offer made by the requester. And now, once all this is set, we need to prepare a new screen for both the roles. In this case, the responder will receive the response screen with the value. You are now the responder, and then the requester offers you so many euros. Do you accept this offer? Okay. And then the requester, meanwhile, is waiting. So he receives the default wait screen. This is what you saw during the demonstration. All right. And now what happens if the responder clicks? Let's say he clicks on accept or decline. So this value is stored in the get action performed. it'll come, it's configured here. And then from the acceptance, based on the acceptance, if he did not accept, then both of them receive 0. Otherwise, both of them receive the value that we set here in this part of the code from the requester. Again, there is some logic for logging, and I'll again come to this in a little more detail. So the end of this, the end period method is called, which kind of defines the result screen for both of them. So the main point of this screen is to determine the payoffs of each of the roles. So in each round, we keep track of what is the payoff of the person using the requester.getPayoff. And then in this case, we just keep adding the values that we get as logic, right? And then yeah, you have to also call the update subject method to update the payoff. And after this, we also have new trials to log some more information about the payoff. And then finally, there are 2 new screens, which is the ultimatum results the game result screen. The same screen which is shown to both the requester and the responder. And in both cases, they get the message as to what the requester and the responder gets. All right. And then what we do is show screen with deadline, because we want to show the screen for 5 seconds. And then we want to wait for 1 minute between the 2 screens. And then we want to show another screen with deadline, which is the default waiting screen to both the roles. So this kind of brings to end this experiment. And then at the end of it, we say this dot finished equal to true to denote to the main institution that everything has been done and the next period can start. Right? So this is in brief the institution. So one part that I skipped in this description was the trial object. So for example, the trial object can be used to log any kind of data to the database from any part of the logic, either from the institution, or that is either from the server or from each client at some particular activity. For example, here the payoff is stored as a value, as an event. The screen name is also set. So each trial object consists of several parameters, and these parameters will have to be configured. For example, the subject group, the value, the screen name, the event, the subject, the server time, and then finally you have to call the create new trial. So the value that you are interested in is actually the set value, which denotes the value that you would like to store. In this case, it's the payoff. And you can basically store any kind of values from your experiment as strings. You can also concatenate multiple strings and store it as values. And then another thing that you can do is set event. So you can say that the event that I'm talking about is the payoff event, and this is my value. Or you can also say that the event that you are interested in is the response, and then you try to record whether the responder accepted or not, and stuff like that. So you can use the trial management in any way in order to log specific events of your experiment to be exported later as CSV files or whichever you are interested in, right? So this is one thing, and then back to the server package. So we have the institution and the environment. So a little more detail about the environment. So like we saw, the institution extends the environment, always implements the environment. Okay, so in this case, we see that the environment has 2 main components, which is the requester. So basically, whatever is common between all the treatments of an experiment can be saved in the environment. So I'll continue about the environment in the next part. Thank you for your attention so far.